My name is Belinda Malachi, and I will be presenting today's life science section. Can you hear me? Okay. Make sure your audio is turned up. Okay. Make sure that your speaker volume is also turned up. Please note we are having connectivity issues, and for that sake, we will be switching off my camera. So you won't be able to see me, right? This is to make sure that you guys can hear. Okay, if you want to send any questions, you can send them in the question box. Okay, should you have any questions, please send them on the question box and I will email you the feedback. Okay, you can download this presentation on the handout section. Okay, as we wait, right? Asking you guys to raise your hands if you want me to repeat something that I went through. Okay, just to make sure that everyone understands and that we are on the same page. So please, when I ask you to do that, you please respond. Right? Okay, so I'm just going to allow some time for everyone to join in. Okay, you will not be able to see me. Okay, this is to solve our connection problems. Okay, so sorry about that. I do have 2 eyes, a nose and lips. I'm a complete human. Okay, I'm a complete human. Okay, I'm gonna allow a couple of minutes for everyone to join in. Download the handouts so long, download today's presentation so long. Okay. By show of hands, please indicate if you can hear me. Okay, by show of hands, if you can hear me, please indicate with your hand before I start. Okay, if you can't hear me, please try leaving and rejoining the session. Okay. All right, I see most of you can hear me. All right, all right, all right. Okay, so you can put your hands down. Thank you so much. Okay, I'm going to allow 1 more minute. Okay, get water, get your pen, your paper, whatever it is that you think you're gonna need, get that ready. We will start shortly. Okay, so I will start now. Okay, so today we will be looking at homeostasis. All right, so on different curriculums, different curriculums assess this in different terms. So some curriculums will assess this only in term 3, some will assess it in term 2. Please just check, make sure with your curriculum provider if this will be examined for term 2 or term 3. If you are on the impact curriculum, please go into your facilitator's guides to check if it is examined in term 1 or term 2. Okay, just make sure in your facilitator's guides. Okay, but in any case, we will be doing that today. Okay, so homeostasis is the maintenance of a constant environment in the body. Okay, so in order for us to function properly, certain factors or substances in our bodies need to always be in a perfect balance. Okay, we call this optimum, or the best balance for our bodies to function at. So this means we need the right amount of temperature, okay, which is about 36 to 37 degrees Celsius. Okay, that's the temperature that our bodies need in order to function properly. Anything more than this needs to be brought down to this. Anything less needs to be brought up to this. Okay, so homeostasis is that process of maintaining the balance. It's the maintenance of a constant environment in the body. Okay, so we'll be looking at temperature, we will be looking at water, okay, we'll be looking at salt, we'll be looking at glucose, and we'll be looking at carbon dioxide regulation. I'm going to repeat that. In this session, we're going to be looking at the regulation of temperature, we're going to be looking at the regulation of water, we're going to be looking at the regulation of salt, we're going to be looking at the regulation of glucose. We've touched on this in the previous session when we were doing the endocrine system, because one of the glands work in maintaining, one of the glands, the pancreas, works in maintaining the glucose levels. And we will be looking at regulation of carbon dioxide in our bodies. Okay, so as I've said, in order for our bodies to function properly, all this need to be in a perfect balance. Okay, so for just to make this session more interesting, this is not going to be examined. What I'm going to touch on now is not going to be examined, but it's just so you can have an idea of why our body needs to maintain a balance for this substances. Okay, so we're going to start with temperature. Okay, so in order for our bodies to function properly, remember we have enzymes in our body that assist with our metabolic activities. So for those enzymes and other things to work in our bodies, we need a normal body temperature of 37 degrees Celsius. Okay, so this means if it's a hot day, your body, we will look at how your body does that. Your body will bring it down to 37 degrees Celsius. Okay, but if you keep on getting too much heat, okay, your body might suffer from what we call heat exhaustion. Okay, like I said, you will not be examined on this. Okay, this is just for enrichment. So this means if your body keeps on absorbing heat without rest, it will get what we call heat exhaustion. Okay, and from there, if that also keeps on going without the body resting, we will suffer from what we call a heat stroke. Okay, which can cause convulsions and it can lead to a coma sometimes. Okay, so but before it can get to that, your body is going to try and maintain it. Your body is going to try and bring it down. But just like you need to rest when you're working, if it's overworked, it might lead to a heat stroke. Okay, but our body helps in getting rid of unwanted heat. Okay, again, water. Too much water in your system causes what we call water poisoning or water toxicity. Okay, so poisoning does not only come from dangerous substances like cyanide and alcohol. You can get intoxicated by water, too much water as well. Okay, so because the kidney can only process about 800 to 1,000 milliliters of water per hour. So if you go beyond that, it's going to be too much for the kidneys to process, and this can cause water poisoning. Okay, which also leads to seizures. Okay, I've said that word correctly. I normally say seizures or seizures. Okay, it's a seizure. Okay, so water poisoning causes seizures, and sometimes it can lead to death. Okay, so too much water for your body for your kidneys to get rid of causes water poisoning. Okay, and too little water causes what we call dehydration. You can get dehydrated, and that also has its own impact. Okay, salt. Okay, also too much salt is not good for your body. So if you're eating too much salt, your body is going to try and bring it down, but too much of it is dangerous. Okay, so what salt does, salt has sodium ions. Okay, salt has sodium ions in your body, and they work in retaining water. Okay, so the sodium ions help in retaining water. Okay, but this water retention causes pressure. Okay, this extra stored water causes pressure. Okay, so too much water retained in your body will cause blood pressure. Okay, and it will put strain in your kidneys. Okay, so this means your kidneys won't be able to get rid of water as it's supposed to. Okay, so this can lead to kidney diseases. Okay, your body tries in maintaining the balance. Okay, glucose. Your body secretes hormones. Okay, so I'm going to ask you guys to participate a little. What hormones are released by your pancreas? Okay, please type your answers in the question box. What hormones are released by your pancreas to regulate sugar, to regulate glucose? Okay, please type your answers in the question box if you know it. Okay, what hormones in your body released by the pancreas help in regulating glucose levels in your blood? Okay, if you know the answer, please type it in the question box. Okay. Okay, I see a lot of you said insulin and glucagon. That's 100% correct. Okay, someone said, yes, insulin, that's 100% correct. Somebody said glycogen. Glycogen is not a hormone, okay? Glycogen is not a hormone, okay? The hormones are insulin, which helps in breaking down glucose. So it helps in bringing down the glucose levels. And then glucagon brings it up. Okay, so if you have too little glucose in your blood, the Glucagon will help raise it. Okay, thank you for your answers. Thank you for participating. Right, so the two hormones that help in regulating glucose are insulin and glucagon. Okay, so without insulin, it means your body will have a high rise of glucose without stopping. Okay, this is what we call diabetes. So people with diabetes their bodies do not naturally produce insulin. They'll have to inject it to themselves so that it can help in breaking down the glucose and turning it into glycogen. Right? If you have too little sugar in your body, symptoms can be tiredness and so forth. All right, carbon dioxide also. Too much carbon dioxide levels in your body can cause problems. Okay, it always needs to be maintained. Okay, so too much carbon dioxide levels can cause unconsciousness and respiratory arrest. All right. Okay, so those are the problems that are associated with these substances if they are not kept in check. Okay, so but our bodies help a great deal in making sure that a balance is maintained. All right, let's get to it. So our bodies make sure or maintains balance by what we know as negative feedback. Okay, so negative feedback works in the body to detect imbalances in the internal environment and bring them back to normal. So negative feedback mechanism works in the body to detect imbalances in the internal environment inside our bodies and bring them back to normal. Okay, so this is what happens. This is the steps that negative feedback follows. Okay, or this is what we call the negative feedback mechanism. Firstly, an imbalance is detected. Okay, and then the control center, depending on what imbalance was detected, the control center will get stimulated. When it's stimulated, it will send messages to the target organ. It all depends on what imbalance we are working with. We're going to be looking at the different target organs that are affected by the substances that we're going to be working with. Okay, so an imbalance is detected, and then the control center gets stimulated. And then it will send a message to the target organ. Okay, the target organ will then respond and reverse the imbalance, and then balance will be restored. Okay, so first your body needs to detect that there is an imbalance, and then the control center gets stimulated, and then a message will be sent to the target organ. Okay, depending on what imbalance was detected, then the target organ will respond and reverse the imbalance, and then your balance will be restored. Okay, unless you are sick. Okay, if you are sick, your target organ might not respond accordingly. Or if your body is tired, we've mentioned that your body can regulate temperature, but it needs to rest sometimes. Okay, so sometimes it might not respond normally. Okay, so we're going to start with temperature, regulating how your body regulates temperature. Okay, so in order for the cells in the body to function properly, humans need to maintain a constant temperature of 37 degrees Celsius. This means that even if it's hot outside or cold outside, your body is working hard to make sure that inside us, we maintain 37 degrees Celsius. Okay, so we're going to look at how that is done. Let's start with a hot day. Okay, we have our Mr. Smiley there in his shades, indicating that it's hot. Okay, so obviously your body will detect that it's hot. Okay, Then the control center, in this case, will be our hypothalamus. Okay, remember we said the control center will be stimulated. Okay, so in this case, it is our hypothalamus. It will be stimulated to send impulses to the skin. Our target organ is the skin. Okay, so it's hot outside. Your body detects that there is an imbalance. Your hypothalamus, the control center, will be stimulated to send impulses to the target organ, the skin. When it gets there, okay, so the blood vessels in your skin will dilate. Okay, this is known as vasodilation. They will become wider. So the hypothalamus will will be stimulated. It will send impulses to the skin. It will inform the skin to dilate the blood vessels. Okay, this is just an example. The blood vessels will be dilated. This is known as vasodilation. So a normal blood vessel will have a smaller diameter than this one. Okay, it's wider. Okay, when this happens, okay, more blood will flow to the skin. Okay, and this will result in heat loss. Okay, so I'm gonna repeat this. In a sunny day, when your body detects that it's hot outside, the hypothalamus will be stimulated to send impulses to the skin. In the skin, the blood vessels will dilate and more blood will flow to the skin, resulting in heat loss. Okay? Again, more blood will be sent to sweat glands. I apologize for that typo. It's supposed to be sweat. To sweat glands, and then they will become more active. Okay, and then from there, the liquid sweat will evaporate using heat from the skin. Remember, even outside, for evaporation to occur, we need heat. The heat causes evaporation to occur. So as the heat is used, your body cools down. So as the heat is used to evaporate the liquid salt, the body cools down. Okay, so more blood flowing inside the blood vessels reduces the heat, and evaporation from the skin reduces the heat as well. Okay, but most importantly, you must remember this process for examination. Vasodilation causes a reduction in heat. Okay, so you must remember that. All right, if you've got questions, please send them. Please send them on the question box, right? So again, I'm going to ask you to please raise your hands if you would like me to repeat this process. Can you please raise your hands if you would like me to repeat what I just said now? Okay, I see we have a couple of hands that are up. I'm going to repeat it. Okay, so let's just go back to the negative feedback mechanism and how it works. So first, an imbalance is detected. Okay, so it's hot and your body can feel that it's hot. And then the control center gets stimulated. Okay, so we're going to see what our control center is when we're working with heat. Our hypothalamus will be our control center. It will get stimulated and it will send impulses to the target organ, which in this case is our skin. Okay, then from there, it will cause the blood vessels to dilate. This process is known as vasodilation. And as this happens, more blood will flow to the skin, resulting in heat being lost. Okay, again, more blood will be sent to sweat glands, okay, in the skin, and they become more active. As they become more active, the liquid sweat will evaporate from the skin using the heat. And as the heat is used, body cools down. So this is how your target organ works to restore balance. Okay, this is how your skin works to restore balance. Right, let's go to the next slide. Okay, so now what happens when it's cold? Again, if it's too cold, your body must bring the temperature back to 37 degrees Celsius. Okay, so your body will detect an imbalance, that it's too cold. Okay, our control center for temperature is the hypothalamus. The hypothalamus will be stimulated to send impulses to the skin. Our target organ for temperature is the skin. Okay, so their blood vessels will not dilate now, they will constrict, they will become narrower. Okay, this means that less blood will flow to the skin, resulting in less heat lost. Okay, so in this case, blood vessels will constrict to prevent more blood from flowing into the skin. This will result in less heat being lost. So a wider blood vessels result in heat being lost, a narrower blood vessel result in heat being kept or conserved. Okay, the process whereby blood vessels constrict to save temperature is known as vasoconstriction. Okay, so this is how a normal blood vessel would look. This is how a dilated blood vessel looks, and this is how a constricted blood vessel looks. Okay, when this happens, less blood is sent to sweat glands. Oh, there's the swear again. I'm so sorry. Sweat glands, and they become less active. So when it's hot, they become more active. But when it's cold, the sweat glands become less active. This decreases the evaporation. Okay, this means that not a lot of heat is being used. Remember, we need this hot to keep warm. So less cooling will happen. All right. But although your body helps in keeping you warm, you still need, sometimes it gets very cold and you still need some nice coats and fireplaces and so forth to keep warm. All right, so this is a reverse of what will happen if it is hot. Okay, next let's look at how water levels are controlled or regulated. If you've got questions on temperature, please post them on the question box. Right? So, according to your knowledge, I would like you to participate again. How many liters of water are recommended? How many liters of water are recommended for an adult? How many liters of water are recommended for an adult? Who knows? Can you please send me answers? Whoever knows how many liters for an adult? Okay, not kids. For an adult, yeah, man or woman. Okay, so we need about 3 to 4 liters of water per day. Okay, so if you said 2 liters, that's 100% correct. By 3 to 4 liters, I mean some of the food that you eat with your food. Okay, so but we need about 3 to 4 liters of water per day. Okay, we've seen that too much water can cause death. Sometimes it can cause water poisoning, which can result in death. But your body will try to regulate it, bring it down or bring it up when it needs to. Okay, so let's see how water is regulated. Okay, if you drink water, okay, sorry, this person, my cartoon here must come here, and that person who's drinking water must go there. So please just swap those cartoons around. I swap them around. Okay, my gym buddy there must come there. He's low on water. Okay, so if your body detects a low water level, this is what's going to happen. Okay, the control center, which is the pituitary gland, will release more ADH. Okay, so if there is a low water level, the pituitary gland, which is our control center in regulating water, will release a hormone known as ADH. It will release more ADH. This ADH will help our target organ, which in this case is kidneys, to reabsorb water. This means that less water will be passed out as urine. Okay, and therefore water levels will be brought back up. Okay, remember, if you are low on water, the control center, your body will detect that your water levels are low, and then the pituitary gland will be stimulated. It will release more ADH, which will go into our target organ. Okay, it will cause our target organ, our kidneys, to reabsorb water and pass out less urine, and then this will bring water levels back to normal. So less water will be passed out as urine and more water will be reabsorbed. Okay, but if you have high water levels, remember I said that human must come here, okay, and that must go there. If you have high water levels, the control center, pituitary gland, so water levels are connected to the pituitary gland. The pituitary gland will be stimulated to release less ADH. Okay, so less ADH means that the kidney will reabsorb little water and more water will be passed to the bladder, and then water levels will be back to normal. Okay, let's look at the time. Does everyone understand? Can you please raise your hand if you understood what I said now? Can you please raise your hand if you understood what I said now? Thank you, thank you. If not all your hands are up, I will have to repeat it. Okay. Okay, not everyone's hands are up, so I will repeat this. If your body detects that there's a low water level, the pituitary gland will be stimulated to release more ADH, which will cause the kidney to reabsorb water and pass less urine to the bladder, and then the water will be restored back to normal. But if your water level is too high, the pituitary gland will release less ADH, so less water will be reabsorbed into the kidneys and more urine will be passed into the bladder, and then water levels will be brought back up. Okay, next. Let's look at salt. Okay, So if the salt levels are low, the control center, in this case, our adrenal gland, okay, found on the kidneys, okay, will release more aldosterone. Remember, the adrenal gland releases 2 hormones, okay, one of which is aldosterone. Who remembers what is the other hormone that the adrenal gland releases? If you remember, please type it in the question box. What is the other hormone that is released by the adrenal gland? Please type it in the question box if you remember. In this case, we looked at aldosterone. That's the hormone that works in regulating water. But what other hormone is released by the adrenal gland? The adrenal gland is found right above on top of the kidneys. Okay. Okay, yes, adrenaline and cortisol. Thank you, guys. Right. But in this case, for regulating salt levels, it will release more aldosterone. Okay. This aldosterone will help the blood vessels to reabsorb the sodium. Remember this, we want the sodium inside the salt. So releasing more aldosterone will help blood vessels to reabsorb the sodium. Okay, and then the salt levels in the blood vessels will increase, and then salt will be back to normal. So our target in this case will be the blood vessels. Okay, so if you have too much salt in your body, the adrenal gland will release more aldosterone, which will cause an increased reabsorption of sodium into the blood vessels, and then salt levels will be brought back to normal. But if you just ate popcorn and your salt levels are high, the adrenal gland will release less aldosterone. This means that less salt will be reabsorbed to the blood vessels, and then the salt levels will drop. They will go back to normal in your blood. All right. Controlling sugar levels. Okay. So in this case, we have 2 hormones that are being released from the pancreas. So if your body detects an increase in glucose, the control center, the pancreas, will be stimulated to release insulin, okay, which will go into the liver, our target organ, and what it's going to do is it's going to the insulin in the liver is going to change the glucose into glycogen to be stored there, and then glucose levels will drop. Okay, so if your body detects a rise in glucose, the control center, pancreas, will release insulin into the target organ, which will then take the glucose, change it into glycogen to be stored and used later. Okay, like when you're on a diet, and you are not eating a lot of carbs. Okay, so if you're on a diet and your glucose decreases, the pancreas, our control center, will be stimulated to send insulin into the liver, where the stored glycogen will be changed into glucose, and then the glucose levels will come back to normal. Okay, all right. Carbon dioxide. Okay, so during exercise, you have learned last year when you were doing cellular respiration that when you exercise a lot, carbon dioxide is produced. Okay, So during exercise or other activity, your cell metabolism increases and produces more carbon dioxide. Okay, so more carbon dioxide will dissolve into the blood, okay, forming carbonic acid, which will lower the blood pH slightly. Okay, remember your pH levels start from 1 to 14. 7 being neutral, anything less than 7 being acidic. So more carbon dioxide forms lowers the pH, okay, forming carbonic acid. Okay, so the receptors in the brain, after this is detected, after too much carbon dioxide is detected, the receptors in the brain will sense that there is a drop in the pH level. Okay, from there it's going to send nerve signals to the lungs, our target organ. Okay, and it's going to increase the breathing rate. Okay, when you breathe, you inhale oxygen and exhale carbon dioxide. So increasing the breathing rate means your body will remove carbon dioxide. Okay, so then from there, the blood pH will rise, returning to normal, and then the carbon dioxide levels will be steady. Okay, let me repeat that. During exercise or activity, carbon dioxide is produced. Okay, it will dissolve into the blood and it will form carbonic acid. This means your pH will drop because it's now acidic. So your receptors in the brain will sense the drop in pH levels. It will send signals to the lungs, asking it to increase the breathing rate. Okay, so the increased breathing rate will quickly remove carbon dioxide from the blood, and then the blood pH will rise slightly and return to normal. Okay, this brings us to the end of our presentation. Okay, these are the only factors that we're going to be looking at: temperature, cool, warm, water levels, high, low, salt levels, high, low, sugar levels, high, low, carbon dioxide, high. Right, so those are the only factors that we're going to be looking at. Okay, so this brings us to the session. If you've got any more questions, please type them now, or if you'd like me to repeat something, because we still have a bit of time left. If you want me to go through to repeat one of the things here, please type it in your question box. Okay, I'll wait for you guys. Is there anything you would like for me to repeat? Okay. Okay, somebody asked what causes some people to sweat regardless of temperature when it's cold. Sometimes you sweat if you have an infection, or if you are stressed, or if you are anxious. Okay. Yes, the mask has its own, the mask that we are supposed to wear during COVID has its own side effects, but the side effects that come with wearing a mask are better than contracting this COVID-19. So we have to have them on. Otherwise, it can make us very uncomfortable. I've also experienced that. Okay. Okay, somebody asked that I go through the salt again. Would you please just repeat the head functions or topics? Okay. Do you mean the topics for the whole 2 terms? Or do you mean must I repeat the topics for this session? Can you please clarify on that? Must I repeat the topics for the whole term? Or do you mean the head topics for this session in particular? Okay, so if you mean for this session, the subtopics that we look at is the regulation of temperature, okay, regulation of water, regulation of salt, regulation of glucose, regulation of carbon dioxide. I'm going to repeat again. Regulation of temperature, regulation of glucose, regulation of salt, regulation of water, and regulation of carbon dioxide. I think I was fast. I'm going to go slower. Temperature, water, salt, glucose, and carbon dioxide. Okay, somebody asked to go through salt. Okay, but they have left. It's fine. I will email them back. Okay, so if you still have any more questions, please just send them to academics@impact.co.za and I will respond with an email. Okay, so this, together with the topics that we've done, concludes what you needed to learn for term 1 and term 2 for some of you. And for some of you who are only doing homeostasis in term 3, you are one step ahead. So this means now what you need to do is you need to go back to term 1 work. You must revise, do a bit of revision there, revise the work that you did this term. Okay, don't study like parrots. Okay, when you study, you must study with understanding. Right, so try and make it practical. Try and make what you're studying practical. Try to visualize it. Okay, if you're speaking of water levels, imagine those water levels being high and imagine the cells in your body drowning in it. Okay, and just try and visualize it because it makes it easy for you to understand. Go back, study thoroughly, create yourself mind maps with summaries of what you have learned. When you create a mind map, try not to go back to your book. Try to do it from the top of your head. So you would have studied, try to do it from the top of your head, and then use the mind map that you have created together with your textbook to see what important points you have missed out on the mind map. From there, download past papers and then start seeing how questions are asked, how questions on different topics are asked in your in question papers, and look at the mark allocation. Okay, and then look at the memo to see how they are answered. Okay, from there, try and test yourself time and time again, and you should do well. You should get distinctions in this thing. Okay, only if you study well. Right. Thank you guys for joining me. Remember to keep safe, wear your masks. All right. I'll see you again next time. All right. Bye.